Welcome back to another video. In my previous video, we looked at how to implement a machine learning model to perform sentiment classification on the IMDB dataset of 50k movie reviews. In this video, we'll be performing sentiment classification using neural networks. All the links mentioned in this video can be found in the description box below. If you are new to this channel and like my content, please hit the like button and smash that subscribe button and turn on bell notification so that you don't miss any updates. Stay tuned. So first, let's import the required libraries. So, we are importing Pandas for basic data operations. We are importing Matplotlib, Cbonds, and Plotly to generate various visualizations. We are importing style to set the style for our plots, and here we are using the style ggplot. We are importing RE to use a regex function. We are importing portstemmer to perform stemming. We are importing stop words to remove all the stop words, and then we are setting the stop words as English. And then we are importing word cloud to plot the word cloud, and then we are importing tf-idf vectorizer to vectorize the documents, and finally we are importing train test split to perform train test split on our data. Now that we have imported the libraries, let's read the data from the CSV file. And then let's use a head function to see the data. Now let's use a shape attribute to see the size of the dataset. As we can see, there are 50,000 entries. Now let's get some more details about the dataset using the info method. So now we have an idea of the number of rows and columns. Now let's use a count plot to view the count of the different sentiments in our data. And let's add a title to it. And as we can see, the data set is highly balanced. Now let's print the first 5 reviews along with their sentiments. So there we have the first 5 reviews in our dataset along with their sentiments. Now let's find the number of words in each review. To do this, let's define a function. So this basically takes in the text reviews, splits the review text and then returns a count of words in it. Now let's apply it to the data frame. Now let's see it using the head function. Now we have a count of the number of words in the review. Now let's use this word count to see the distribution of the positive and negative reviews. So similarly, let's visualize the length of positive and negative reviews. Before moving on to text processing, let's do one more thing on our data, and that is to convert the target column into numerical format. So let's replace the positive values with 1 and negative values with 0. Now let's see the modified data frame. Let's now proceed to process the text data. Data processing is done to make the data into a usable format. There are different steps involved to convert the data into a usable format. You can do them individually on the text data, or what I'm going to do here is to create a function that does all of my text processing, and then I'm going to pass my data into it. So if you've been following my videos for a while, you must have been familiar with this step. So let's define a text processing function. So here we are performing lowercase conversion. Here we are removing the break tags, here we are removing the URLs, and here we are removing the hashtags and the @ symbol, and here we are removing the punctuations, and then we are removing the stop words, and finally we are returning the process data. Now let's apply this pre-processing function on the text data. Now let's check for duplicates in our data. We can perform that by using the duplicate function. So let's take account of all the duplicate entries. As we can see, there are a lot of duplicate entries in our data. So let's remove the duplicate reviews. Now there's one more thing left to do, and that is to perform stemming on the data. Here for this project, I'm going to use Porter stemmer. You can also use any other stemmer such as Lancaster stemmer or Snowball stemmer, or even lemmatization instead of stemming. The Python codes to perform these are there in my tutorial videos. So now let's perform stemming. I'm defining a function here as well. Now let's apply stemming to the process data. Now let's apply the word count to see the change in the number of words. And as we can see, the number of words have reduced after applying pre-processing. Now let's visualize the positive and negative reviews using the word cloud. So let's first separate the positive and negative reviews, starting with the positive reviews. Now let's use a word cloud to visualize the positive reviews. Next, let's visualize the most frequent words in the positive reviews. For this, I'm going to use a counter. So let's import the counter. Now let's count the different words in the positive reviews. Now let's put it in a data frame. Now let's visualize the data using a bar chart. Now we have a visual representation of the word count of the different words in the positive reviews. You can make it more colorful by adding colors to the different words. Now similarly, let's do it with the negative reviews as well. So first let's apply the negative reviews. Now let's use a word cloud to visualize the negative reviews. Now let's count the words in the negative reviews. And then let's convert it into a data frame. Now let's plot the most frequent negative words. Now that we have processed the data, let's split the data into X and Y. As we are creating a sentiment analysis model, our X data will contain the verified reviews of the users and the Y data will contain the feedback of the users in terms of the sentiment polarity. Now that we have split the data, let's vectorize the data before moving on to model building. So here I'll be using TF-IDF vectorizer to vectorize the data. So let's load the TF-IDF vectorizer and fit transform the data. Now let's split the data into training and testing set with a test size of 30%. Now let's print the size of the training and testing data. For training the neural networks, I'm going to take a smaller subset of the entire data to make the running easier and also to reduce the computations. You can vary this based on the computational power of your system. Now let's print the size of the reduced training and testing data. There's one more thing left to do before building a neural network. and that is to convert the X data into an ND array. We will be using toArray to convert the X data into an ND array. Now let's import the libraries to create a neural network model. So we are importing sequential, as sequential helps to create a neural network model layer by layer, and then we are importing dense, as dense is used to define the dense layers in a neural network. So now let's define a neural network model. So here we are loading the sequential library so we can add layers to our model. Now let's add the first dense layer to our model. Here I am going to set 16 number of neurons for the first layer with a ReLU activation function. For the first dense layer, we also need to specify the size of the input dimension. So this is going to be our input layer. Now let's add the second layer, and this is going to be a hidden layer, and I'm setting 8 neurons for a hidden layer with a ReLU activation function. Now let's set the output layer, and since the output has only 2 values, I'm going to set one node for the output layer with a sigmoid activation function. Now that we've specified the different layers of our model, let's define the optimizer, the loss function, and the metrics used for the model using model.compile. These values can vary based on the application, and here I am using RMS prop as the optimizer, binary cross entropy to calculate the loss, and accuracy to measure the model accuracy. Now let's run the network after fitting the training data. Here I am specifying a batch size of 10 and epoch of 15. Batch size is used to indicate the number of samples being passed through the neural network at a given time. Epoch indicates the number of times the neural network is trained with the entire training data. Usually, training a neural network for a large number of epochs can lead to improvement in the accuracy of the neural network model. We can also see a summary of the model that we created using the model summary function. Now let's evaluate the model performance by measuring the accuracy and the loss on the test data. Now let's plot a graph of accuracy and loss to see the changes over the epochs. As we can see, now we have a visual representation of how the loss and accuracy changes after each epoch. So that was our first model configuration. Now let's try a different model configuration. But this time, instead of changing the network layers, let's change some model optimizer to see if there is any change in the model performance. So for this network configuration, I'm going to set the optimizer as Adam. Now let's run the model. As we can see, the second model becomes more stable, faster when compared to the first model configuration. That brings us to the end of this video. Hope you got an idea of implementing neural network model on the IMDB dataset. Please don't forget to leave a like and subscribe to this channel if you found this video useful. Thank you for watching and see you in the next video.